Yeah, we're given the graph of a polynomial function, and we want to find the function itself. So to do this, what we want to do is first start with picking out where the zeros are and talking about their multiplicities and how those connect with factors. So zeros mean the same thing as x-intercepts. So as you can see on our graph, we have -3 as a zero or x-intercept. Looks like +2 and then +5. Okay, from here, let's think about whether they touch or cross the x-axis at each one of these. I would say at -3, we go across the x-axis, so I'm going to label that as cross. At 2, we touch and come back on the same side of the x-axis. And at 5, we cross. All right, now that helps us because it helps us determine the multiplicity for each one of these zeros. Evens touch and odds cross. All right, so the first multiplicity, we said it crosses, so that has to be odd. So I'm going to go with 1 in this case. Touch has to be even, so let's go with 2. And finally, across, let's go with 1 for an even there. All right, now as we build this up, I'm going to call our function f of x. At this point, we should be getting comfortable with zeros and factors go hand in hand. All right, I'm going to get a factor that goes along with that -3 for a 0. So 3 is going to be part of this, and an x has to be part of it as well. We have to get the right sign, though, that if I plug a -3 in for our x, it has to make this factor equal 0. So in this case, it's going to be x plus 3 in that factor, x minus 2 for the next factor, and x minus 5 for the last one. Same idea that if you plug in a 5 for that last x, 5 minus 5 makes 0, therefore that factor is 0, the whole thing is 0. All right, next let's attach in the multiplicities. We said multiplicity 1, 2, and 1. Multiplicities are connected to their associated factor for each 0. All right, the last thing we have to take into account is there could be some sort of multiple going on out in front. What I like to do is just put an a out there. A is going to be kind of a placeholder for now. We're going to find a in just a second. It's going to be some sort of number. So to find that, I think the easiest way to go about it is find the y-intercept. So the y-intercept in our case is on the y-axis. That's the ordered pairs 0, -2. So 0 is an x value. If we replace all of our x's in the function with 0, we should get a y value or f of x value of -2. So what I'm going to do is I'm going to use that information and the function that we're building up, and I'm going to replace f of x on the left side with -2. I'm going to replace each of the x's on the right-hand side with 0. So 0 plus 3, 0 minus 2, that quantity squared, and 0 minus 5. Still raised to the first power. I dropped those exponents of 1, though, because it doesn't mean a whole lot. We usually don't write them. All right, from here, we now have a and a bunch of numbers. So we just need to solve down for a. We have 3. 0 minus 2 is -2 squared, it becomes 4. And 0 minus 5 is -5. So at this point, we have a times, I think this all works out to be 60, -60 on the right-hand side. To get a by itself, we'll divide both sides by -60. And a little bit of simplifying, we're going to get a is 1/30. All right, so what we're going to do is take that value for our a, go back to where we had it out in front here, and all we have to do is replace it with 1/30. And there's our function that would give us this graph. Hope this helps out as you're working on going from the graph of a polynomial function to the function itself. Good luck.